All right, here are the notes for 6-3. It says, proving that a quadrilateral is a parallelogram. You see some theorems here. These theorems are almost the exact reverse of the properties on 6-2. 6-2, they say, hey, you got a parallelogram. That means opposite sides of a parallelogram are congruent. Opposite angles of a parallelogram are congruent. The diagonals of a parallelogram bisect each other. Well, what this one was from 6-2 is you're given a parallelogram, these parts are congruent. What this is going to do is say, okay, here are certain parts that are equal, that makes our figure a parallelogram. So you've got these blank pictures, you don't know if it's a parallelogram or not. And so if you're looking at some type of four-sided figure, and if you notice, both pairs of opposite sides are congruent, then this four-sided figure must be a parallelogram. So it's kind of like the converse of for the parallelogram figures. If you notice, hey, parallel, 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 then this thing must be a parallelogram. Okay. So again, you're starting with some blank quadrilateral. You don't know anything about the quadrilateral, but if certain tick marks occur, then you know it is a parallelogram. So let's read the next one here. It's theorem 6-6. If both pairs of opposite angles are congruent, then this thing is a parallelogram. So if you notice, oh, 100 degrees, 100 degrees, 80 degrees, 80 degrees. If you've got opposite angles equal, then this thing has to be a parallelogram. And the final one is, you've got this figure here, and you're going to try to determine if it's a parallelogram if the diagonals bisect each other. So you go corner to corner on one, corner to corner on the other. I'm just quickly drawing that. And then if you notice that, this is 4 inches, 4 inches, 6 inches, 6 inches. And if you notice they bisect each other, then the figure must be a parallelogram. And so all of these first three are the three bullets that we mentioned here on 6-2. When you have a parallelogram, all of these parts are equal, opposite sides, opposite angles, and the diagonals bisect each other. There is going to be one extra one here, and this one is a bit strange here, but here it is. It doesn't have a matching theorem from the previous work. If one pair, not both pairs, but one pair of opposite sides of a quadrilateral is both congruent and parallel. So if I notice, hey, that's 7 inches, this is 7 inches, and not only that, it's parallel, then the quadrilateral is a parallelogram. So even though you don't have any information on the left and right of this picture, it is fine, this thing is a parallelogram. Alright, so here are the types of problems you're going to see on 6-3. You're going to be given a picture. They all kind of look like parallelograms. Everything looks parallel, but you don't want to go based on appearance. You want to determine if the four-sided figure quadrilateral is a parallelogram based on the tick marks. So number one, for example, I've got parallel, parallel, and then I got equal, equal. Now, is that enough information to be a parallelogram? Well, if you recall, if both sides, opposite sides are parallel, or if both opposite sides are equal to each other, then it would be a parallelogram. This has one side that's parallel, one side that's equal. This is going to be no. And the reason why it's no is because this could technically be, if I draw it correctly, parallel, parallel, equal, equal. This could be an isosceles trapezoid. Now, if you look back at the original picture and go, well, that don't look like an isosceles trapezoid. Again, you are not judging by appearance. You're judging by the tick marks. All right, number two here. I've got diagonals, tick, tick, and a tick and a tick. Well, this is theorem 6-7. If the diagonals bisect each other, then this four-sided figure must be a parallelogram. So yes, this is enough information to know for sure that's a parallelogram. The diagonals cut each other in half. Number three. Tick, 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 tick. These are opposite angles that they are equal. This is 6-6. If both pairs, and it has to be both pairs, of opposite angles of the quadrilateral are congruent, then it is a parallelogram. So this is definitely a yes. There's no way this is going to be a trapezoid. There's no way that this is going to be a kite. It has to be a parallelogram. All right, and finally this one. Well, this one's an interesting one here. We've got tick, 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 tick. But that's it. Now, we've never mentioned, if I look at this just from without that one diagonal cutting through the middle, these two ticks together would add up to this tick here. But that's just one pair of opposite sides. Now when you draw the diagonal here, there is no rule, well, if I draw a diagonal, is this thing a parallelogram? You got to realize, okay, the triangle on the top, it has two angles that are equal to two angles that are equal on the bottom. And when two angles of one triangle are equal to two angles of the other, then the third angles must be equal. And what happens now is you've got both pairs of opposite angles being equal. Yes, this is a parallelogram because both pairs of opposite sides are equal. Okay. Also, these two original triangles are equal because of angle, side, angle, angle, side, angle. And when they are equal, then corresponding parts inside congruent triangles are going to be equal. And then once I tick mark all the side lengths, opposite sides are equal, which makes it a parallelogram.